Today we'll be working on lesson 6.3 exponential and logarithmic forms of equations. This video is for my academic class, and remember you can always use the calculator. Okay, so let's start with the first question. You have to solve 3 to the power x is equal to 9. So ask yourself, what can you raise 3 to? What power to give you a 9? So 3 to the power 2 is 9, so x is equal to 2. So this was easy to solve. Now if you move on to the next example where you have to find x, where 3 to the power x is equal to 7. Now, what can you raise 3 to what power to get you 7? Now this is harder than the first problem, and that's why we're learning how to use log to solve problems like that. But before we move on to see how we can use log to solve problems like that, let's try to find a pattern between exponential functions and logarithmic functions. So let's move on to the second part. 3 to the power 2 is equal to 9. To write this as an exponential, from exponential to logarithmic, you would write log base 3 of 9 equals to 2. To write 2 to the power 5 equals to 32 as a log function, you would say log base 2 of 32 equals 5, and 5 to the power negative 2 equals 125. You would write log 5 of 125, 1 over 25 equals negative 2. So what's the pattern? Before we move on and discuss what the pattern is, let's review some vocabulary. 3 to the power 2 is equal to 9. So what would you call 3? 3 would be called the base. 2 would be called an exponent. And the 9 would be the answer, or we're going to call it an argument. The argument. Now, as you can see, in every single problem, the base of these exponential functions became small numbers next to the g. So the big 3, the base, became a small number next to the g. The 2, also a small number next to the g. The 5, a small number next to the g. Now, the exponent in every single base, or in every single exponential function, became an answer. So basically, it is on the second side of your equation. And the argument in each one of them is now inside the log. So what is the pattern? Let's take the first one. If you take log base 3 of 9 is equal to 2. As you can see, 3 to the power 2 would give you 9. So 3 to the power 2 will give you 9. So let's start naming them. So the number that's small over here, we're going to call it the base from now on, because it's the base in the exponential function. The exponent over here will still be called the exponent over here, so you can tell how they are similar. The argument is going to be still called the argument over here, so you write that inside the log you will always have something called the argument. So again, 3 to the power 2 would give you 9. So let's see how we can apply this. In the second problem, they're asking us to, based on these examples, write a general rule using the words exponent, base, and argument. So from here we're going to say that the base, if you raise it to an exponent, it will give you an argument. This is an exponential function. Now to write the same thing using the logarithmic function, you would write log, and the base is going to be a small number on the bottom next to g, and we're going to put the argument in parentheses next to the log, and this will be equal to the exponent. So what have you noticed? The log is always the exponent. The answer of the log is the exponent. So how do you say it? When they give you an example like that, you would say log base 2 of 8 is equal to 3. Again, it means that 2 to the power 3 would give you 8. So the answer of the log is always an exponent, as you can see. So let's move on to the next problem. Write each equation in exponential form. Now, how can you write this as exponential form? Remember, 2 to the power 3 is equal to 8. So this is one way to write it. Now let's move on to the other one. Sorry for the mess. Let's erase this. Okay. Now let's move on to the other example. Log base 2 of 1 over 4 equals to negative 2. You would write it you would write it as 2. The base to the power negative 2 would give you 1/4. So 2 to the negative 2 would give you 1/4. I'm going to do one more. I'm going to do number 5, and you can do the rest on your own. So 16 to the power 1/4 would give you 2. So 16 to the power 1/4 is equal to 2. That would be your final answer. So again, the base raised to this exponent will give you the argument. So make sure that you memorize those terms. Now let's move on to the other example where they're asking us to change each equation into a logarithmic one. So remember, the base should be written as a small number next to the g. And then the exponent will be on the other side of the equation because it's now the answer of the log. And the argument, or this number over here, is going to be in parentheses inside the log. So you say log 2 of 16 is equal to 4. Now to check your answer, you can always do the arrow thing. So 2 to the power 4 is equal to 16, and it gave you this answer. I'm going to do 2 more. So the base would become a small number next to the g. The exponent will be your answer, and this will be going inside the log. Now there's something that I would like you to pay attention to. Some of you, like whenever you're trying to write your answer, you write 32 big enough, so I would read it like log, and I will think that it's 32 to the power 2. Try to have some distance between those two numbers, and let this be a small number next to the g. So this has to be clear that is a small number next to the g, and not a number inside the log. So some of you might write it this way, and then I will think that you mean log of 32 to the power 2. So you have to be careful and to try to write 32 as a small number next to the g. So one more. Let's move on to number 11. So again, the base, you write it as a small number next to the g. The exponent will be the answer, and this one will go inside the log. So log base 5 of 1 would give you 0. Now this is the front page. Now let's move on to the back page. And here where you need to use your calculator. Now I know in here it says evaluate the following logarithms without using a calculator. I'm gonna tell you using the calculator. You will always be using a calculator to solve something like this. Now how would we do number 13 through 20? To do something like that, log base 10 of 1,000, you can do the following. First of all, you go to math. So let's write down the steps. First of all, you go to math. Then you scroll all the way down until you get to log base. You see that? Log base. Once you click log base, you press enter. As you can see, over here, you are asked to enter the base and the number. Now the base, as you can see, is 10, so you enter 10. And the number inside the parentheses is 1,000. So you enter 1,000. Then you press enter, and that would be your answer, 3. Now let's try another one. Let's try 18 if you want. So again, math, move all the way down to log base, press enter. You have 3, and inside you have 1/3, so you can write as 1 divided by 3, or you can do the alpha y equals thing, it's the same thing, and you will get -1. Now let's try 16 again. Math, go all the way down to log base. There you go. Press enter, and now you need to have a 4 and -16 on the inside. Now let's see what the calculator will tell us. Non-real answer. So this is no solution. And this does make sense. Remember what we said about logarithms? You can never have a negative inside the log. You can never have a 0 inside the log. So every time you see a negative, like log of a negative number, you can directly say that there's no negatives, there's no solution. So non-real answer, it means it's impossible. Now let's move on to other questions. So I think you get the idea for 13 through 20. Now let's move on to 21 and 22. Now, as you can see in this case, I do not know what the n is. So if I try to do math and then go all the way down to log base, I don't have a number to enter over here. So every time you have an unknown inside the log, the first thing that you should do is try to change it to exponential. So let's write this down. To change the log to exponential. So let's try to do that. Remember what we said? Let me make this bigger. So the base to the power 4/3 would give you n. So 8 to the power 4/3 would give you n. Now this is something that you can enter in the calculator. So you put 8 to the power 4/3. You press enter, and then the answer is 16. So n is 16. Now again, if they give you a problem like that, to solve it where you have n or unknown inside the log, you would change it to exponential function and then use the calculator to solve it. So 27 to the power 2/3 would give you n. So 27 to the power 2/3 will give you n. And again, 27 to the power 2/3 would give you 9. So n in this case is 9. So that's the whole lesson. So let's try to review. What did we learn today? Let's go back to the first page. We learned that we can change between exponential and logarithmic. Logarithmic means exponent. So to change between a logarithm and an exponent, you know that the base to the power of this one would give you the argument. This is how you change between log and exponent. The base will become a small number next to the log. The power would be the answer of your log, so it's on the other side of the equation, and the 9 would be the number inside parentheses over here. This is how you change between logarithm and exponential, and between exponential and logarithm. Now let's move on to the next page. We also learned how to solve logarithm. Like if they give you log of base 10 of 1,000, you can just enter it in the calculator by going to math and then log base, enter the base, enter the argument, and then you will get your answer. Now, let's see if this makes sense. 10 to the power 3 is at 1,000. 10 to the power 3 is equal to 10 times 10 times 10, which is 1,000. So if you want, you can check your answer this way. Now to change or to try to solve logarithmic equations, to do that you have to change from logarithmic to exponential, and you do that because you have the unknown inside the log. So if you try to go to math and then log base, you don't have a number to enter. Let's show you what I mean. You don't have a number to enter over here, it's an n. We don't know how to do that, so you try to change it to exponential. Some of you will be tempted to do the following. So go to log base, and then you would put, okay, let me move on. Okay, so some of you would try to go to math and then log base, would enter 8 over here, and then you would enter x over here, and would press enter thinking that this will give them the answer, but then it will not. So if you enter this to your calculator, it will not know what to give you. So you need to change this to an